In this video, I'm going to show you how to do the calculations from Chapter 5 on your TI-84 calculator. So we're going to start with just a probability distribution. So I'm going to go to Stat, Edit. I need to clear this list. So I'm going to go up to L1, hit Clear, Enter, and then I'm going to type in my probability distribution. So I'm going to pause the video while I do this. All right, so I have my probability distribution typed in, and in Chapter 5, Section 1, the only calculation you needed to do with a probability distribution was to find the mean, the variance, and the standard deviation. And so to do that with this list, I'm going to go to Stat, over to Calc, I'm going to do one var stats. I need to change list to my first list, so L1, that's where my random variables are. So I do second L1. Now the probabilities are going to go under frequency list, so I need to change that to second L2, and then I go to calculate, and that gives me my mean. And you'll notice that it doesn't give me anything for a sample standard deviation, so the calculator recognizes this as a probability distribution. So there shouldn't be a sample standard deviation, only a population standard deviation. So that's 1.116. And if you wanted the variance, all you have to do is square this and you will have the variance. Now let's talk about binomial probability distributions. And so the first thing I'm going to show you how to do is to create the entire binomial probability distribution table. So I'm going to go to Stat, Edit, and I've cleared my L2 list because this is where my binomial probabilities are going to be. The first thing you need to do, though, is make sure in your L1 you have all of your random variables typed in. You're just going to type these in like you would any other values. But you want to make sure you do start at 0 and go all the way up to n. So recall that n is the number of trials. So you want to do 0 to n. Now in L2, I'm going to show you how to put in those binomial probabilities. So I'm going to cursor up until I have L2 highlighted. And then I'm going to do second distribution. And under that, I'm going to cursor down until I see binomial PDF. So you have a PDF version, you have a CDF version. You want to pick PDF. Now it's going to ask you for number of trials. In this case, I've got 5. My probability of success, let's just say that's 0.3. And then leave this X value open, but then go to paste and enter. And your calculator will fill those in for you. Okay, so that is if you need to create the table. So using the table, I can answer questions like, what is the probability of getting exactly 2? That probability would be 0.3087. Or what is the probability of getting exactly 4? That would be 0.0284. So if I wanted to just calculate a single probability and I didn't need the table, let's take a look at how we'll do that. So I'm going to do second quit. And let's suppose we have this problem from 5.2. I believe this is example 2. I don't remember exactly, but given that there is a 0.05 probability that a randomly selected adult smartphone owner is cashless, find the following probabilities. So the first two probabilities I'm going to find is exactly none and exactly 2. So let's go back to the calculator and I'll show you how to do those. So we're going to go back into that distribution menu we were before, so second vars, and we're going to go down and find that binomial PDF function. So binomial PDF, this is what you're going to use if you want to calculate exactly. Now, for the question that I just pulled up a second ago, n is our number of trials, and that was 10. The probability of success was 0.05. Now this time I do need an X value because I'm only going to do this one calculation. I want the value of 0 successes. Paste, enter, enter again, and you will get the probability 0.599 if I round that to 3 significant digits. Now, this PDF function is what you're going to use for any binomial probability that wants you to find the exact number of something. Now, remember in question 2, I wanted to know what is the probability of getting exactly 2. So I can go back through second vars, go back into the distribution menu, but actually the easiest way to do this is just to do second enter. And this function of your calculator will bring back the last function that you use. So now all I have to do is cursor over and change that from 0 to 2. And that probability is going to be 0.0746. Now, our next questions are not going to ask us to find the value that exactly X number occurs. It's going to be a range of values, so for multiple values of the random variable. So our next question is find the probability of 3 or fewer. So if I'm talking about 3 or fewer, then I want the probability of 0, 1, 2, and 3. And so I could do the binomial PDF of exactly 0, 1, 2, 3 and add them all up. But I have a function on here that's going to make that easier. So if I go into second vars and I go down to where your binom PDF is, I want you to look at the binom CDF. So this is cumulative. So it will add up over a range of values. So I'm going to hit enter. My number of trials is 10. My probability of success is 0.05. And my value for X is 3. Now, one thing you need to know about this function is it's going to give you the sum of the probabilities from 0 up to what X is. So I'm going to get the sum of 0, 1, 2, and 3. Now, depending on how my question is worded, I'm going to have to adjust this a little bit. Okay, but this one is 3 or fewer. So when I hit enter, that probability is 0.999 if I round to 3 significant digits. Now, our next question, I skipped this one because I want to do this one first. Our next question is find the probability that more than 8 are cashless. So more than 8 would be 9 and 10. So remember that binom CDF is going to go from 0 up to X. Then for this one, I need to calculate the complement. All right, so what I'm going to do on my calculator is I'm going to do 1 minus binom CDF of 10 with a probability of 0.05, and I'm going to go up to 8. All right, so I'm going to do 1 minus, and then go back into second vars and go down and find that binomial CDF. 10.05, and then this X value has to be 8. All right, so what I'm actually doing here is I am finding the sum of the probabilities from 0 to 8, and then I'm subtracting that from 1. So what's going to be left over is the sum of the probabilities 9 and 10. Because I wanted specifically more than 8, I am not including 8 in the calculation. So I go to paste, enter, and that gives me 1.8 or 1.9, and then remember this is times 10 to the negative 11th power. Our next question is going to be the probability that less than 4 are cashless, so less than 4. So that means 0, 1, 2, and 3. We are not going to include 4. So we go back into vars, second vars, go down to binom CDF, enter. Now, I don't want to include 4, so I'm going to stop this at 3. So whatever your X value is, that will be included in your calculation. So I want less than 4. So my X value needs to be 3. Paste, enter, enter again, and that probability is 0.999, since we've already calculated that once. My next question is no more than 2. So I'm going to, so when we're looking for no more than 2, then we want the sum 0, 1, 2. So I can just do second enter to recall that binomial CDF and change this to 2, and then that probability is 0.988. And then our last question, the probability that at least 7 are cashless. So at least 7 would mean 7 or more. So we're going to have to do the complement. So 1 minus second distribution, binomial CDF. And so if we want 7 or more to be in our probability, then we need to end this x value at 6. So we want to do the sum from 0 to 6 and subtract that from 1, so that what's left is going to be 7, 8, 9, 10. Enter. And we get 8.198 times 10 to the negative 8 power. So this is going to be 0.7 zeros and then 819.